Hello everybody, welcome to actually the first video of this channel, and today we will be learning how to factor quadratic equations of the form ax squared plus bx plus c is equal to 0. And now, for starters, before we get into some of the problems I have prepared for you today, what factoring form essentially looks like is going to be two components of a product, so right over here, with x's in each of them, and also some other number that we don't know about, which I'll call beta and alpha. And so essentially all our endeavors of factorizing a quadratic equation will be aimed at making that equation look like exactly what I've written here. This product of two sort of mini components that together give us 0. And from here, we use something called the zero product property, which is essentially when we have two numbers multiplied together that give you 0, then either one number is equal to 0, the other number is equal to 0, or both of them are equal to 0. So that's the zero product property. And to apply it into this context, it'll give us x plus beta is equal to 0, so therefore x is equal to negative b, and x plus alpha is equal to 0, and x is equal to negative alpha. So this is essentially how you turn whatever you have in the factored form of the quadratic into a concrete answer. So therefore, these will be the solutions to your quadratic. Now, for the first question, we're given x squared plus 5x plus 6 is equal to 0, and we want to place it or put it into factored form. Now, the way we do that is to find two numbers, so two numbers which multiply to the c value here, which is 6, and add to the b value, or the b coefficient, which is 5. And the way we go about finding this pair of numbers that meets this specific set of conditions is, well, first to find the different factors of 6 and to list them out and use a bit of guess and check work. So let's see what multiplies to give you 6. Well, for starters, we can have 1 times 6. We can also have 2 times 3. But also keep in mind that there are the negative components of these guys too. So we can also have negative 1 times negative 6 and negative 2 times negative 3. So all four of these guys, or these pairs, satisfy the condition that they multiply to give you 6. But only one of them will add to give you the number that you desire, which is 5, or the b value. So let's go about checking each and every one of these. So 1 plus 6 gives you 7. We know that that's not right. 2 plus 3, however, does give you 5. So that's good. Negative 1 plus negative 6 gives you negative 7, so also not right. And negative 2 plus negative 3 gives you negative 5, which is also incorrect. So now, based on that, we know that this pair of numbers, or 2 and 3, is the pair that we are going to use to factor this quadratic. And so basically, now, what's left to do is really easy. We just write the factored form of the quadratic, so x is here and there, and we plug in these two numbers into these brackets. So we're going to have x plus 2 and x plus 3. And you might be asking me, well, why put a plus 2? Or why not just a minus 2, for example? And the reason because of that, or the reason for that, rather, is because our two numbers here, 2 and 3, are both positive. And so we always need to make an agreement with the signs when placing the quadratic equation into factored form. So here's our answer. And if you want to find the solutions to the quadratic, then you're going to have two sets. Each component equal to 0, So you're going to have x is negative 2 as well as x is negative 3. Now, for our second question, we're given something very similar, which is x squared minus 7x plus 10 is equal to 0. And just like we did before, we are going to find two numbers which multiply to 10 and add to negative 7. So let's list out 10's products. Well, we can have 1 times 10, 2 times 5, negative 1 times negative 10, and negative 2 times negative 5. And let's see their sums. So 1 plus 10 gives you 11, which doesn't work. 2 plus 5 gives you 7, which also doesn't work. Negative 1 and negative 10 give you negative 11, which is not correct. And negative 2 plus negative 5 is the only pair that does give us this b value that we're looking for. So let's go ahead and box that. And from now on, just like we did before, we're going to put this quadratic into factored form. So 2 brackets, which multiply to give you 0. And we're going to make an agreement with these signs while plugging them in. And here is our factored form. And if you want to solve the equation, like I said before, you're going to use the zero product property, setting each and every one of these factors equal to 0. So we're going to end up with x is equal to 2 and x is equal to 5. Now moving on to the third question, we're given negative x squared plus 4x minus 3 is equal to 0. And at first, this might seem just like the other two examples that we did. However, there's something crucially different, which is, as a matter of fact, so let me change colors, this negative 1 here, the a coefficient. And it turns out that if you have anything other than 1, so here, let me write that down. If a is not equal to 1, then standard method doesn't work. And so what do I mean by that? Well, what I mean is if we go ahead and apply the same procedure where we find two numbers which multiply to negative 3 and add to 4, we're going to sadly not get the correct answer. So first, in order to make sure that the a value is not this negative 1 over here, what I'm going to do is perform a bit of initial factoring. So I'm going to take out the negative 1, which is akin to switching the sides of each of the terms or the signs. And we're left with something that indeed does have an a value of 1. And so now we can start using our standard methods and find two numbers that multiply to 3 and add to negative 4. So let's list them out. We can have 1 times 3. And, well, it turns out we can only have one more case, which is negative 1 times negative 3. And of these two different pairs, only one of them adds to negative 4, which is this guy. So this is our pair. And from here on, we can place this quadratic equation into factored form. And always remember this negative 1 over here. It doesn't just disappear. Okay, so these two multiplied together gives you 0, and we are going to make an agreement with the signs, giving us a final factored form of negative 1 times x minus 1 times x minus 3 is equal to 0. And finally, if you want to find the solutions to this quadratic, we are going to use, as you've probably guessed by now, the zero product property, which will then lead us to x is equal to 1 and x is equal to 3 as the solutions. Okay. Now moving on to the final problem I have for you. which reads 2x squared plus 3x minus 5 is equal to 0. This one is perhaps the most challenging of the bunch because there is quite an anomaly at the beginning, which is the fact that the a value is not 1, not -1, but 2. Now, some of you may be tempted to just say, well, okay, we can do the same thing with the one before, which is to factor out this 2, leaving us with this quadratic, which, well, I'll just say is completely factorable. But the thing is, it may be slightly more complicated because of all these nasty little fractions like 3/2 or -5/2. So this might be slightly more difficult, and so I wouldn't suggest it. However, we're going to do something a little bit more clever. We're going to perform sort of a modified procedure to what we did before. And what I mean by that is instead of finding two numbers that multiply to -5, we're going to find two numbers which multiply to the a value times the c value, which is going to be 2 times -5, which is going to be -10. So we're finding two numbers which multiply to -10 and add to the same b value, which is 3. So now let's list the factors of -10. Well, we can have -1 times 10. We can have 1 times -10. But we can also have -2 times 5 and 2 times -5. So here are our 4 cases. And let's see which one does work. So adding these together gives us 9. Adding these together gives us -9. Adding these together gives us 3, which does work, matches our b value. And adding these two together to a -5 gives you -3, which doesn't work. And these don't either. So therefore, this is our pair of numbers. Now, at this juncture, we come to our second major complication, which is the fact that, well, if we just go ahead and take our two numbers and plug them into this factored form that we've been doing before, so if we plug in -2 and 5, and assume that this is our final factored form, you'd be sadly mistaken because this, in fact, is not the case. Because, and I'll prove it to you why, if we expand this so-called factored form via FOIL, what we're going to be left with is x squared plus 5x minus 2x minus 10 is equal to 0, which reads, after some simplification, x squared plus 3x minus 10, which is equal to 0. And this is not equal to our original expression. And that is how we know it's wrong. Because if our final factored form gets expanded and doesn't match what we originally have, well, we know we've probably done something wrong in the process. So instead of just merely doing this, so let me just move this aside so it doesn't block our view of things. So instead of doing this, as in plugging the numbers into our so-called factored form immediately, what we need to do is something called decomposition, which basically means that we're breaking down the b value, or the b term, which is 3x, into two smaller component terms that are easier to factor. And what that's going to look like is 2x squared, and we're going to break up this 3x term into, or let me just write it the other way, into minus 2x plus 5x minus 5 is equal to 0. And this all is derived from this pair of numbers that we found over here via our previous sort of manipulations. And at first glance, this large expression of 2x squared minus 2x plus 5x minus 5 is equal to 0 seems a lot more complicated because now we have 4 terms instead of 3. But that in fact, isn't really the case, because if we look over here, we can see that, well, let me just change colors again. We can see that there is a common factor of 2x within those two terms, and a common factor of, oh, let me do that again, of 5 within these two terms. And what that means is that we can actually pull those out. So here, we're going to be left with 2x times x minus 1. And over here, after pulling out the 5, we get 5 times x minus 1. And all of this is going to be equal to 0. And just by analyzing this new equation of ours, we see that these two guys, they both share a common factor of x minus 1. And because of that, we can pull yet another thing out again. So we're going to be left with x minus 1 times what's remaining, which is 2x plus 5, because we're taking this guy out. All this is going to be equal to 0. And, well, voila, you have your factored form. So this is the final factored answer. And you can see that it did take a variety of steps to get to. So therefore, I guess it can be concluded that for the cases of quadratics where the a value is not equal to 1, there are a few more manipulations to do, and so it might seem initially slightly harder or more difficult to grasp at first, but I promise you that later on, with more practice and more exposure to this topic, you will improve your skills, and quickly. So in order to facilitate that, I've posted a practice problem set in the description of this video. So if you'd like to check that out, it's completely free. There's going to be, like 5 or 6 questions there, and you can do them to your leisure.